So as I was saying, this is the last day of classes. There's a practice PDF that you should go over. Um, and we're going to basically go over it today. Uh, but you know, if you haven't done it yet and you go, even if you go through it in class today, I think I would still suggest kind of going through it fresh just to try it on your own and see how that goes. The final is this Friday, and I was just saying before I started recording here that we'll probably do a 24-hour window to do it. So maybe either, I don't know, just from midnight to midnight on Friday kind of thing. And I'm still exploring is one other possible way to take it that's not Canvas or this ProctorU through Gradescope. They have like a quiz mechanism. It's a little untested, so I need to kind of try a few things out, but I think it'd probably be a slightly better experience than Canvas. But it'd be similar to the Canvas one in the sense of it being some multiple choice and a few fill in the blank and a few text boxes to write a little bit of stuff. So any questions about the logistics, even though I haven't really provided that many details except for the rough time?
How does ProctorU work?
Oh, well, we're not going to be using ProctorU, but the way it works, as far as I understand, is that when it's practically malware in the sense that it insinuates itself into your computer operating system and locks down the internet, and then you have to provide a webcam so that you're recorded taking the test, and as a microphone is on so they can hear any if you're talking to someone about it. So it's a pretty invasive program to kind of try to prevent people from doing other things on their computer when they're taking a test if it's not allowed. So again, that seems to be the answer that a fair number of places have settled on, but I don't know, it just seems a lot to ask, and some people don't have webcams and all that kind of stuff. So I'm happy not to do it. So someone's asking, my webcam isn't working, what can I do? Well, we're not using ProctorU, so I'm not going to be staring at you taking your test. And the final basically be the same kind of structure as the midterm in the sense of like kind of open notes. And I'll try to look at that again and make sure that's sort of reasonable. Let's see. Okay, so let me ask a question. So this class, Competent 10, you're supposed to kind of learn the basics of Python, variables, assignment, functions, loops, if statements, working with lists, a few things like that. What do you think, if you had to say like three themes or three things in this, big things in this course in 1020, what might you say are some of the big themes?
I'd probably say like classes and inheritance and like which goes where.
Yeah, really, and the big one is classes, right? I mean, that was the big add-on structure to plain functions that we added. And again, there's a lot of sort of details to how those are built. And then there's a lot of sort of design kind of things about how you use them. And those are but that's the big thing, I think, the object-oriented programming, which is expressed through making classes in Python. And then part of that classes thing is the inheritance thing, which again doesn't, is both sort of complicated, like it adds to me a whole bunch of complication, and maybe it doesn't feel like you get a lot of win out of it. But where do you think you get some use out of inheritance? Like what's an example of something where we got some value hopefully out of doing some inheritance? And you can feel free to add to the chat, or you can talk out loud. Both are useful, I think.
I would say like it helps you not write more than you need to. Like you can just reuse a lot of stuff instead of like writing a bunch of complicated stuff and then getting lost and like not being able to figure it out, when it's like you can just reuse stuff basically.
Yeah,
right?
Yeah, and like, so can everyone give an example of where that happened?
in the recent, well, two of our assignments. Actually, I think it was specifically 6. That we had to create some more variations of bee, zombies, and plants.
Yeah, so
But
I
we
think
still but we still have access to their like their health or their speed or whatever they had from the original base class.
yeah, you do some work building up a base class structure that's sort of generally useful, and then you write some specifics, like the particular zombie, particular plant that somehow, hopefully in your cases, were not particularly long, but they still had all that built-in stuff that let them work. And so that's a good example of it. And again, if you're doing like 2 kinds of zombies, it's sort of like, well, I could have just cut and pasted that thing and it wouldn't have been that bad. But like a normal game might have 40 different kinds of these things, and you'd certainly get tired of cutting and pasting them from one file to the next. And then let's say you decided to change how the health worked, you'd have to go into each one of those 40 things and adjust them, basically, right? So as projects get bigger, this object-oriented approach is useful. It's just hard for us to put in the time to write something that's so complicated that it seems like a clear win. And then we were sort of forced to use inheritance in making user interfaces. And so, for example, we wanted to make a custom widget. We inherited from a basic widget, and then we could add stuff like a counter or something like that into it and let it behave that way. But that whole thing is structured in a way that like you really don't have a choice in some cases to kind of, or at least to do it well or easily to avoid inheritance. And there, the inheritance was almost just sort of like forgotten because you just sort of inherited from a widget, and then your thing just started acting like a widget, and you sort of just didn't even really think about it very much. Like it just sort of was natural. And so that was a funny case in some ways that the inheritance didn't seem like a big deal, but actually was really the glue that made it all work together. So, okay, so I think those, just keep those in mind that, you should, if those are the 3 things, sort of normal classes with inheritance, and then using them in user interfaces, I think that should give you some structure to think about how this is all happening. Okay, so, and there was just about list comprehensions. List comprehensions were a big part of the class in the sense that I think it's a very useful, very Python-y kind of useful thing to do to kind of make your code just be a little more concise and maybe a little more, well, I want to say readable, but it's sort of less readable until you get used to it. Then it's maybe more readable. But certainly you should be thinking about list comprehensions as one of the big tools we've been working on. All right, so what do you say? Should we go through this practice PDF? Let me share. What should I share? I think because the problem is I want to have like a PyCharm open and that PDF, which gets a little complicated. So I guess I'll just share my entire desktop. And so let me just get some of this stuff out of the way first before I do that. Okay, share big old desktop. And this is gonna be kind of weird because you're gonna like see yourself. Well, actually, I'm not really sure how it shares. Like, do you see my little Zoom gallery when I share the desktop? Or is that hidden somehow? Like, do you see the little thumbnails that are not your thumbnails of Zoom, but my thumbnails of Zoom? I'm just curious. Okay,
No, it's hidden.
Okay, that's good. Otherwise, that would definitely be confusing. So it's smart enough to grab the part underneath the Zoom part. Okay, so let's see. There's my PyCharm, and here's this. So again, even though it seems maybe a little, I don't know, I want to say basic, but not programming is the sort of talk about terminology. But again, there's a lot of lingo we sling around, and I think it's very important to make sure, when I ask something or I say a program should act in a certain way using that lingo, if you don't understand the lingo, you're at a real disadvantage just trying to figure out what is going on. So this first one, a blank is a type of function as part of a class. So let's throw some answers up on the chat, and then we'll talk about it. And you should, again, choose from up here. Okay, good. There's some good. answers. Everyone's saying a method. So again, a method is a specialized term for a function that is part of inside a class. And the thing that really distinguishes a method from a function is that it has access to the stored information in the objects of that class through self. So inside that method, normally in a function, the only thing you'd see in a function are local variables. So ones that you define or initialize, for the first time inside the function. You can see parameters, so things that are passed into the function. And then you can kind of sloppily use these global variables that were just defined sort of randomly unindented in the file. And so those are all things in a normal function you can use. But a method can also find the things that are stored in the object. So the self.name, self.age kind of stuff. And it's in some ways it provides a balance between this sort of just give it access to everything you want in the whole file, which is again sort of dangerous in the sense that it's hard to tell where things get changed, and then things that are in this particular scope of the class. And so it's sort of a balance people decided it was a nice thing to do. So you didn't have to pass it in as a parameter, but you could use it in there, but it's pretty well understood why you could use it because you're a method of the class. Any questions about that? And again, there's one thing to sort of say method, another to kind of have a deeper maybe understanding of the nuances of how one applies and the other one applies. Okay, so a blank relationship defines one class to be is a kind of another class. And hopefully, since we were kind of just talking about that, your inheritance answers sound good to me. There is another kind of relationship we talked about briefly, and then and so instead of saying like a cat is a kind of animal, what's another kind of relationship you could have between two pieces of data or two classes? So we have a zombie as a kind of, enemy. A student is a kind of person. Those are all inheritance things, right? So instead of inheritance, what's another way of making a connection between, for example, two classes? So not child, not inheritance. And I only kind of sort of formally talked about this a little bit when I was introducing inheritance. So scope, not quite where I'm headed with that. So let's say you have a car that has an engine. You wouldn't say again that like an engine inherits from car or car inherits from engine because they're not really related to each other. So how would you make a connection between those two kinds of classes, car and engine? Not really anything to do with PYQT except for you've been using that mechanism in PYQT some, but it's all right. So we have an attribute, and an attribute is what we also been calling an instance variable. And so you can say that like a car has an engine by making an engine object be an attribute or instance variable of that class. So in some ways, that's sort of the default way that we think about these relationships, because that was the first way we learned it, right? We said, okay, here's a class and it has a string name in it and a integer age in it, and that has a relationship. A person has an age, a person has a name, and so it's not a is a kind of thing, it's a has a, and that is through an instance variable, and that whole process is sometimes called composition. So you compose these two things together. All right, so again, for two very simple questions here, we're just trying to fill in the blank. I was maybe going a little overboard on the explanation there, but I'm trying to kind of review as much as we can here. Okay. And I wasn't really, like I said, I wasn't planning to give a 10-minute monologue on those, but I get carried away, right? So now just because we're talking about sort of big fancy classes and things like that doesn't mean we should forget about all the basics, right? So we have a list. Hey, how come I can't like select stuff? Okay. Barely. Okay, given a list of vowels, 1, 2, 3, 4, what would be stored in vowels after vowels dot append 5? There's a lot of options coming through. That's good. There's always a good way to test this stuff. Let's go take a look. So Python console. Oops, what did I just do? Python console. Go up. Okay, vowels equals 1, 2, 3, 4. And again, I'd really encourage you, especially looking at this kind of stuff, after you answer it, just go play with that code a little bit, right? Get it set up so it's not hard to do. Like before you start, like get a little test file going and a little console up, and just tell yourself you're gonna sort of try these things all out. Just so one, you can kind of confirm your answers without having to like post a note on Piazza or something like that, which is also fine. But you know, it gives you a chance to try different variations, right? So vowels dot append 5 print vowels 1, 2, 3, 4, 5. So the job of append is to modify this list. So some things make a new list. So for example, if I said vowels plus, whoa, where did I click? 6. What is this going to do? Diego, can you say something? No? Okay, so answer is make a separate list. Okay, so here's the thing. I just typed this, and I'm still not actually 100% sure what it did. I have a list here printed out, 1, 2, 3, 4, 5, 6. And but I hit vowels again. Vowels is still 1, 2, 3, 4, 5. So what, as suggested, this thing makes a new list with these values. So it evaluates, this is an expression that evaluates to a new list. And if I wanted to capture that change, I would have to reassign it to a new, either back to vowels or to another list, right? So the way it is now, it just kind of goes away. This one, append, since it's part of the vowels class, it can kind of work directly on vowels. And so append modifies vowels and adds the 5 on the end. Now, there are some people that were worried about out of range index error. I kind of put that there on purpose, saying, you know, is this the number here? Is it a value or is it an index? And if this was somehow like put something at location 5, that would cause an out of range index error. And the other thing is just whether append puts it on the end or puts it on the beginning, and you just have to know that in some ways, right? So there are subtleties here, but the big subtlety to me is that in this case, you're doing what's called a change in place. It modifies the list itself, and so vowels is still referencing that list, but that list has changed its storage. And then the other one, the plus sign or concatenation, only works to put 2 lists together and makes a new list out of it. And so, for example, if I had tried something like this, which is also kind of common, why am I'm clicking on something that's it doesn't like it because it's supposed to concatenate 2 lists together, not a list and a separate value. And so that's why I had to put the square brackets around it up here, is to make 2 lists, one vowels, the other one the 6 list. Okay. So again, even though there's different levels of understanding, the easy level of understanding is append sticks a value on the end of the list. But then there's all, again, and this is where it causes people trouble, is all these nuances to it as to what does that mean, stick it on the end? Does it make a new list? Does it change it in place? You know, all that kind of stuff. And, you know, do I have to have room for it, or does it make room for you? All that stuff. So I understand and I'm sympathetic to the sort of idea that there's all these complications to each one of these sort of simple statements. But our job has hopefully been kind of navigating you through some of those complications and making you more confident in what these do. And of course, there's 2 issues about knowing what it does. One is when you write it, you want to write it the right thing. And 2, when you're debugging it, you have to look at that code and say like, okay, I believe this is going to do this particular thing. And then when you print it out or something like that, if it doesn't do that same thing, you have to figure out why. Is it because you don't understand the statement, or is it because something else is going on? But if you don't understand how the statement works and you don't understand how the rest of your code works very well, then it's very hard to debug stuff. Okay, here's some stuff given a list 1, 2, 3, 4. Will be stored in sum after executing this code here. Some chat answers coming up. And they all look good. 10. So this is something you've probably, hopefully have seen many times. And it's a basic loop to find a sum of things. You have to start off with a variable that initializes your answer that's going to accumulate through the loop with 0. And then we're going to loop over the values in the list. And again, this is, I think, an easier form than sort of going over the range of index values. So we're just going to pull out the values one at a time and add them to sum using the slight shorthand notation here. It means sum equals sum plus value. And, my big fear, of course, for this one is that I actually do my addition wrong or something like that. So I get the wrong answer that way. Like I know the code, but adding 1, 2, 3, 4 together is fraught with danger on its own. So hopefully you don't make a mistake there. And I try not to make problems where you're adding up 3-digit numbers and forced to kind of do harder elementary arithmetic that can make a mistake. Okay, write code for a class called cat that has a sound instance variable. Write an init method with a sound parameter that initializes the instance variable. Add a speak method that prints the sound instance variable. Add code to create a new cat object and calls the speak method. So this question is dense, right? Each line is saying something very specific. And for those of you that, again, are struggling with the terminology, of course, it makes it hard to do this question. But if you know what these things mean, it's not saying anything too complicated. We're making a class cat that has a constructor, the def init, and it has a parameter. In other words, it has value sent into it. And then we have to make an instance variable with that thing. And then we have a method that uses that to print it out. And we want to use it. Okay, so I think we should sort of poke our way through this and not hard to know how to make you chat answer this one. Feel free to quickly write something in chat if you want, but let's see, let's make this a little smaller. Well, we'll have to just refer to it as need be. All right, so class cat, right? Sometimes it takes me a minute to kind of get rolling there and remember how this all starts off. And then we're going to define, oh boy, define an init. And again, that has sort of the weird syntax with double underscore. And the thing I always forget that PyCharm always remembers for me is self. And so I have to let it do its thing. And as suggested, there is an additional requirement here that it has a sound parameter. So again, the parameter part means that I'm going to add in some name thing there. And again, the typical job of the init is to take this parameter and stick it someplace where it's going to be retained in any object that gets made. So self.sound equals sound. And so again, it does seem sort of, it always seems a little bit just like boilerplate or like, make work. It almost would be nice if there's an init that just says, hey, make an instance variable out of each one of these things for you. And actually there are some like IDEs, some like PyCharm type things that will kind of do that sort of stuff for you a little bit and make setters and getters and all sorts of stuff. But that was all it was supposed to do. And in this case, sound it's hard to know what it is, but since I'm going to print it later, I'm guessing it's a string, right? That whatever a cat says. And so then our second job was to add a speak method. So again, that's a def indented inside the class cat speak, and it gets self. And again, there's a temptation, what should I say to add a parameter of some kind? But again, usually with classes, what we're going to be using is some built-in value and just use it in some form. So I'm going to just print the self.sound. And this is what I was talking about earlier in the sense that there's not a sound passed into this thing. There's not a parameter sound. There's not a local variable sound. But we can use the attributes or instance variables of the class in this method. So it's a new mechanism for getting values in there. And the reason we do that is we're trying to stay consistent. If I pass in woof to the cat speak for what it should say, well, that's flexible, but it's weird. Cats shouldn't say woof, right? So we want to make a cat be set up properly, and then whatever it speaks is whatever was stored in it. And hopefully those are consistent. All right, so add a speak method that prints out the sound instance variable, and then add code to create a new cat object. So when I say add code to create a new cat object, I'm really talking about adding code outside of the class. So something that runs like in a main, and in this case, I'm just going to say it unindented, my cat equals a cat, and it says, I love you. I'm sure my cat's trying to say that all the time when it's yelling at me at 6 in the morning for food, right? So hopefully this has made a cat that stores that as its sound. And then I want to use this cat, my cat, to speak. And so I say, my cat speak. And again, I'm not telling it what to say. I'm just trusting it to say whatever it normally wants to say. So if I run this, I love you. All right, it worked. My cat said something nice to me. I'm happy. That's all I had to do, right? So, you know, you probably should expect something in the final being something similar to this, where you're making a, and you know, this is sort of like the one kind of example we've done a lot of, which is a person with a name and an age, and then it prints out, hi, my name is David and I am 12 years old, kind of thing, right? And so make sure you can kind of get through these basics. Okay. Any questions about this? Now's your chance to finally figure out what these instance variables are if you haven't already. Okay, so nothing? You're all happy with that? Nothing? All right. You can return to it if I have moved on. What's next? Evaluating code. And again, the point of evaluating code is, one, it's easier than asking you to write code, but I can still tell if you know what it means. And two, it really is a skill, and that skill that we use a lot to debug our own code. And you have, and there's a certain way you have to force yourself to be a little dispassionate about it, right? Not be emotionally invested in it, but just sort of think about what it is that it does and not let your hopes and dreams get in the way of understanding what the cruel reality of what that code does is, right? So you should only do, you know, you should look at it very closely and just sort of do mechanically what it asks you to do. So here's this first one. We have a function, not even a method, right? A function, a standalone function, we're defining do something, takes in a parameter and adds one to it. Outside the function, we're making a variable x. We pass the x to do something, and then we print out x at the end. So what's going to happen here? All right, some consistent answers. And let's see, last time I tried drawing, for some reason, all this recording and screen sharing stuff I was doing was making the drawing be very poor, but let's try again. So the way to think about this is I like to draw those boxes, you know, like those variables names that are referencing some sort of object, right? So we have x referencing a one int object. So that's what this is doing at this line here. When I have x as an argument to this function, what that means is that val1 here is going to reference the same object that x does. So that's easy enough to write here. Okay, so that's all pretty good. It's the next part that causes trouble because it seems so innocent and yet it is so devious in some ways, right? So val1 plus equals 1. The natural instinct would be to make this thing here as 2, right? But let's unpack it a little bit more. So val plus equals 1 is the same thing as val1 equals val1 plus 1. So how do we do this? We evaluate the right side, the expression on the right, and that says, okay, what value is stored in val1? That's a 1. And 1 plus 1 is a 2, and that makes a new 2 int object. And then we say, hey, val1 is now referencing this 2 object. It's not referencing the 1 anymore, right? And then we leave the function here. So we come back, and when we leave here, actually all this val1 stuff goes away. It leaves scope. We can't use val1 anymore. And we print x. Well, what is x referencing? It's referencing that 1 object still. All right? So that is why, even though it looks like we're changing something that's probably changing this original argument, we're not really changing it. We're using it, but then we're using it to build something new that gets assigned to val1. And again, this is something that caused a lot of trouble. If I want to get this changed value out of here, what should I do instead? So I want to get a 2 out of there somehow and be able to use it down here. What can I do? What's the normal kind of thing to do in a function to let values escape? Okay, so if you print it, it will print on the screen, but I couldn't use it down here. So I could print up here val. I'm really kind of losing my, let me clear this now. Okay, so if I print it there, yeah, it would print it and I could see it. Like that's useful for debugging, but it wouldn't get the value down here to do something with it. So instead what you want to do is return val1 and assign like that back to x or something like that here. So x equals do something x. And so x now equals that new 2 value. All right, so it's where you call it that has to do the work on this. But the other way to think about it is just because you send a value to a function doesn't mean that you can change that original value. All right, this second one now. Almost the same, but a little different. What's going to happen here? And when you go back and maybe go through this test, you should, I think, force yourself to write some of these little boxes and references to see if you understand what's going on. So let's do that. So I've made this first line. I need to go back to drawing. This first line here, make something that looks like this. X references, well, okay, my box is kind of bad, a list. And in the list, the first thing references a 1 object. All right, so there's all these, now there's like layers, and that makes it more complicated. But if I say do something to x, that means val1 references the same thing that x does. So I add in a val1, and I reference this thing here. And then I say, go into that list to this location here and add 1 to it, which says, okay, what does that mean? It says this thing now references this 1 plus a 1, which makes it 2 object. And this spot in the list now references this 2 object, which is not really that readable anymore. And just writing it over and over again doesn't really help the situation. All right, so what that did was, instead of making a new thing that X and val reference, it says it makes a new thing that first element, the 0 index of the list references. So this list now references a 2. Then we left the method here. And in fact, this val1 goes away because it's out of scope. But when I say, hey, print X at 0, it says, okay, what is X referencing? It references this list. And what is that first thing referencing? It's referencing a 2. So it prints out a 2 now. So somehow by packing that 2 or that 1 inside a list, it means the list doesn't change, but the things inside the list can change. And that means it can escape outside the function. And similar kind of stuff works with objects. So I can go into a function and say, hey, ask that plant or that zombie to move. And that zombie would move, and the zombie itself doesn't change, but its internal structure changes, kind of like the list's internal structure change, which means that the change persists when it leaves that method or function. Okay. Any questions on that?
Yeah, just a clarifying one really quick. Were we dealing with the index position or an actual integer with that last problem?
So, like here,
Yeah, I mean, I think I got a little bit confused. Like, I guess, are those lists, or is that like an index position with the?
So here we made a list and has a 1 in it. Here we are accessing the list at index 0.
Okay, thank you.
And I kind of agree. It's a little unfortunate in the sense that the syntax to make a list looks an awful lot like am I multiplying X by a new list with a 0 in it or something, right? You know, like it looks the same, right? But in one case, you're getting into a list with an index, the other one you're actually building a list. Okay, inheritance. Given the code on, let me move this around a little bit here so I can see it myself. Given the code on right, so we have a class vehicle that has a wheels attribute. And write an init method that sets an instance attribute to doors to 2 and uses the vehicle initializer to set a wheels instance attribute to 4. And again, this is where I think the question, it's asking the question that is confusing, and it's not, in some ways it's not answering it. It's trying to understand what is going on here. So there is a superclass. Whoa, that's interesting. And then we have a subclass because it inherits by having the parentheses up here. And when you inherit from it, you have a couple jobs. One is you want to initialize the parent class in your own initializer, and then and there's certain ways to do that, right? So let's see, am I going to be able to write this cleanly enough to work? So let's just kind of finish up. So inside this class car, all of a sudden I thought it said cat again, and I was like, that doesn't make any sense. Vehicle. We're supposed to add in an initializer. Okay, so that means right away, I kind of like, you know, read enough of the sentence where you know where to start and then do it and then go on to the next part a little bit, you know, and kind of def init. I have to do the self all by myself this time. There's nothing passed in. It's all sort of hard-coded things, so I guess I don't need a parameter there. And there's sort of two parts. One is to make a new thing with doors, and then another one to kind of set the wheels here somehow. And there's different ways to do it. The thing that people want to do is just say self.wheels equals 4. But that's not really building up this part up here. It kind of works, but it's like you're just repeating the code again, and so it's not stylistically a good way to do it. The way you want to do it is use this super call and say, hey, I want to access the superclass and tell it to do something. So we don't want to do that. Instead, we want to do super init, and the self part gets handled by itself, but I'm going to pass in 4 here. All right. So again, I think that the issue here that people sort of resist this is it doesn't seem that necessary. You want an instance variable, make an instance variable. But this thing up here is already set up to make a wheels instance variable for you and kind of do maybe other stuff. In fact, we don't really know exactly what it's doing. And And so just because in this case of one instance variable, it seems easy to do it this way, you really want to use the vehicle initializer to set it up the way it wants to set it up. All right, so this is again more of a style issue and a managing complexity issue, but it's the proper way to do it. So when I'm asking to say, hey, use the vehicle initializer, that means the superclass in it. And that's the part that people I think are not getting very easily. Okay, so I've set, this will call this and that'll set wheels to be 4 and that on this new car thing. And then there's the doors thing I have to do by myself and I don't have room for it. So self.doors equals 2 door car 4 wheels, right? So in this case, the doors are particular to the car class. The wheels are shared with the vehicle class. So we want wheels to be set up that way. And it's just something you got to kind of remember, to be honest. All right. But the way I remember is when I have a subclass, its first job is to call this super thing. Like just get it out of the way right away. And now I'm trying to remember. In Java, it's like, it won't let you do it unless you call it right away. Like the very first thing has to be that line. And it won't even run the program. Python's a little more forgiving, but it also then lets you be a little sloppier. Okay. Questions on that? But my main suggestion there is to look at this question and see what, because I know I asked them like that in the midterm too, basically, and make sure you understand that that's the thing you're supposed to do for that kind of question. In particular, this use the superclass initializer stuff. Oops, eraser, no, clear. Okay. Now, once you get into inheritance, especially maybe a longer chain of inheritance, there's some confusion about understanding what kind of methods get called when there's sort of different versions. And that's because there's this idea called, again, overriding, which means a subclass can override the behavior of the superclass by providing a method of the same name and the same number of parameters. And then, but the question is, when does that get used versus other things, right? So here's some code. Class A has a print that prints A. Class B inherits from A, and it has an override of this print to print B. And it has also this print me that, you know, again, the names don't really make that much sense, to be honest, that prints the superclass's print. The superclass in this case is A, so it prints the superclass, uses the superclass print. And then C has an override of B's print, which also overrides A's to print C, right? So, okay, so it's fine to look at that, but in some ways until you sort of try it out, it's hard to force yourself to figure out like, what does it all mean, especially when they're just sort of nonsense ABC prints and stuff like that, right? So here is some code. Make a C object and then call print me on that C object. And the question is, what would print or do? Okay, we're going to a couple answers. All right, so the first question is, if I ask for print me on a C object, where does that come from? It's not.
It from B.
Oh, go ahead.
It's getting it from class B, which gets it from its superclass of A.
So there is no print me defined in class C. And when that happens, it goes and looks up the inheritance chain to say, hey, does class B have it? If class B have it, it uses it. And if it doesn't, it'll go up to A and look for it there, right? That's really what the inheritance does for us. It allows us to not only inherit these attributes, these instance variables, but we inherit these methods. And I think in some ways the methods are the more important part of this. So there's no print me in C, but there is a print me in B. But the print me in B says, hey, use the superclass of B to print. So actually the print here goes to print from A. All right. If this had just said in here, if this had just said print here instead of super print, then it would print B. But it says, hey, instead use a superclass of this one to go up to here. Now, to be honest, even when I said that, I was finally like, well, why is the superclass node go up to A instead of C's superclass? And to be honest, I need to think about that a little bit more. So it's not, maybe it's sort of natural perhaps that you got the B answer because you could be thinking of the superclass of C. And so I need to kind of actually think of what exactly superclass means there. But in this case, it's in the B object and it does a super, and so it prints out A. Okay, what would this do? We make a B object and do print me. Now you're nervous because the last one seemed tricky, but this one's actually a little more straightforward. Okay, so in this case, we make a B object, B inherits from A. We say print me. So the first place it tries to resolve that method call is in the B class. And there is a print me in the B class. But the print me says, hey, use your superclass to do the print. So it goes up to A and prints A again. All right. And it's that super that makes the difference. Again, if that were just a plain print or self.print, or it would have to be self.print. I'm sorry, not just plain print. It would have to be self.print. It would go to this print B here. But the super says jump up a level to the A class and use the print there. Okay, whew. What would this one do? Make an A object and call print on it. Okay, this one is just hard because your brains are kind of scrambled at this point. Oh, you're also, I'm sorry, you know, all you people saying B really were saying print A. So more of you were saying it correctly than I was. I was confused between the A and choice A. So all this, all the B people in the chat, and I think in the recording you're not going to see the chat, by the way. So that's what we're talking about. But you say A print, says, does A have a print method? It does, and so it prints out A. So straightforward. Okay. I was like, man, you're all sticking to saying B over and over again, and I was kind of confused. Give up on the B. It's A every time. But that's what B is.
Exactly.
Yeah. Okay, good job then. Excellent. And if you don't believe me, you can, write some code. Always good to, sometimes, you sort of like, it's easy to be a little mistrusting, I think. And so AAA, right? That's the same code. Write a list comprehender that works on a list called numbers. Create a list with just the numbers and numbers that are between 2 and 10, including 2 and 10. Assign this created list to new numbers. So we're given this list here. It only has numbers between 2 and 10. So 1's not part of it. It'll go away. 3 is between 2 and 10. 20 is not. 10 is because it's inclusive, and 5 is. So it would make a list 3, 10, 5 and assign to new numbers. Yeah, remember that when writing the test, the A and B stuff. It should be like answer 1. And actually, I did a Kahoot recently where I said, what is a square? And then, the Kahoots have those different like triangle, circle, square things. So by the circle one, I put a square shape. And by the square shape, I put a triangle shape. And anyway, I was trying to get people confused with that, but they all got it right anyway. So same kind of problem there. Okay, list comprehension. List comprehension really is just knowing the form of the list comprehension. And it's easy to get confused about where the loop goes and where the if goes and so on. But again, I have a certain way I like to force myself to do it, and you can do whatever you want, but there's sort of 3 parts. There's what the new list is formed out of, there's the loop over the old list, and there's any condition on it. And at least I prefer to make the loop first. So for num in numbers, and then I fill in the part, what is the new list formed out of? It's formed out of num, low num. What's the condition? If num, well, I'm learning that on that's the problem with list comprehensions, they're big, right? If num is greater or equal to 2, and num less than or equal to 10, less than or equal to 10. And the job was to take, this is going to form a new list, and I'm going to assign it to a new thing, new numbers that I'm just going to write real small there. But there's 3 parts. Well, 1, 2, 3, and you definitely need 1 and 2. 3 is optional, and they make long statements. But again, it's sort of a nice way to go through all of the list without having sort of lots of indented code that gets hard to read. And that's sort of the argument for list comprehension. And then in particular for like changing lists, like where you're removing things with a low health or whatever, they're also very convenient forms to use. So, num for num, numbers of num, yeah. Okay, on the chat, there was also, there's different ways of doing that. You're also allowed to, Python lets you do form that looks like that. And that's a nice Python way to do it. Most languages don't let you kind of do that kind of stuff. You have to use like that and or stuff to combine them together, which is why I tend to kind of not usually do it too much in Python as well. But Python, again, is trying to make a nice, concise statement, and that's a good way to write it in Python. Question, we'll have any PyQt5 questions? There'll probably be some PyQt stuff. I know we haven't had maybe as much experience with that. We had a fair number of lectures, and of course all those lectures were in our online phase and probably a little harder to get into. I'm hoping that it'd be nothing that pushes your understanding too much, but a little bit on the PyQt stuff. But I think in there, you should be comfortable. You should understand that the way things happen in PyQt is you use that connect call, and you say, hey, when this button is pressed, click signal, you connect it to some slot, and the slot is just a method of the class that does some action. And that's, to me, the fundamental part of all that. We don't drive the program with a loop. We don't drive the program with some main that has some sequence of instructions. We set up connections between things and define the behavior when those connections are triggered. And that's kind of like the main difference between a event-driven user interface program and just sort of the kind of programs we've been writing up till now. And even different from how Pygame goes, where it's just more like in Pygame, you have a big loop, and every time through the loop, you just say, hey, has anything happened? Has anything happened? Over and over again, which has its own, it's its own style, but it's harder to write sort of complicated things that way. Any last minute questions?
I have one, sorry. I think I misheard you. You said the first part for the new numbers list is not necessary. Like we can put for num in numbers. Like we don't have to put num for num in numbers.
No, you do need that. It was the third part that was not necessary, the if.
Oh, okay.
Yeah. Otherwise, it'd be really, you got to build the list out of something, I guess. So you definitely need that first part.
Okay.
Good question, though. All right, I'm, you can ask a question on Piazza. I'm happy to try to help, and hopefully tomorrow I'll get out sort of a page on the mechanics of the test. But I appreciate you all showing up and still participating, and it's nice to see your faces a little bit here, and I hope the exam period treats you well, and I hope, hopefully, that you'll be able to return to campus, for those of you that are doing that, in the fall, and everything sort of gets back to normal, but we'll have to see, right? So feel free to get in touch if you have concerns about anything, and Anyway, we'll carry on, right? All right. Thanks, everyone. Bye.
Bye. Thank you.
Stop sharing.
Bye.
And stop recording.